Okay, welcome class. This is class 5 of your 601 Quantitative Methods Business Research class. Recall we are not meeting in session today, class session. Instead, you are going to watch this video. I will be here directing through the slides. Unfortunately, this video is not going to get too high tech, but I think it will work just fine. I'm going to go over slides that you can find on Blackboard, usual place under course material, class slides. You can print these out, follow along with me. So we're going to continue hypothesis testing for this video, and it's going to be an extension of the work we did in class 4, except this time we're going to add hypothesis tests for proportions, hypothesis tests for mean differences, and hypothesis test for proportion differences. Now it's all the same procedure, it's just a slightly different nuance when we get to how we conduct those tests. And the only real difference is the sampling distribution for each of these. In class 4 we learned, we used the sampling distribution of sample means to see how unlikely any particular outcome might be. Similarly, we're going to use the sample distribution for sample proportions to figure out how unlikely any proportion would be. Same thing for mean differences, same thing for proportion differences. Now I will say before we begin, you want to be clear and fluent on all of the class 4 material. You want to have a good understanding of hypothesis tests, good understanding of p-value, how we do the critical values. So I would, if you're not feeling great about that, I would go back and review that material before you watch this video. So work the homework problems for class 4, maybe even take the quiz, look at the answers to the quiz, make sure you're comfortable with how all of that works. And if you have to, you could even go back to the class 4 video and watch that again, because that is going to be key to your understanding of this material in this video in chapter 10 and class 5. So once you understand the class 4 material, this is going to be just easy, almost review, and just applying a few formulas. But if you are still a little shaky on hypothesis testing, the place for you to get unshaky is the class 4 material, class 4 quiz, class 4 homework, class 4 video. So I'm going to assume if you're still watching, you are comfortable with hypothesis testing and you're ready to move on to a couple different pieces. They are proportions, mean differences, and proportion differences. We're going to do hypothesis testing for those 3 things. And again, you can get the slides and print them out on Blackboard and follow along with me. In this video, I'm going to do a quick review of class 4, and then we're going to move on to hypothesis tests for population proportion, test for mean differences, test for differences between 2 population means, and hypothesis test for the difference between 2 population proportions. We're just going to add those 3 things in the video today. Alright, so the review, let's do a quick review of hypothesis testing, quick review of two-tailed test, quick review of p-value, quick review of one-tailed test. So hypothesis testing, let me skip to the last 2 bullet points here. In hypothesis testing, we will make a statement. We'll call that statement a null hypothesis. We will assume that to be true, and as we conduct our research, we will operate under the assumption that this null hypothesis is true. If we find overwhelming evidence to the contrary, we will reject this null hypothesis and we will accept what we call the alternative hypothesis, which is the opposite of what is stated in the null hypothesis. So if the null hypothesis is that the mean is equal to some value, the alternative is that it is not equal to some value. Also, we were looking at null hypotheses where the mean is greater than or equal to some value, which would mean the opposite would be that the mean is less than some value. So moving back up here, we make a statement called a hypothesis, and then if we produce sample results that would be highly unlikely under this assumption that the null is true, then we reject it and we conclude that it is false. Okay, so we call this null hypothesis the status quo, no change, and we're going to need compelling evidence to make a change, to say we reject it. This approach will usually involve a decision that will have to be made if the null hypothesis is rejected. For example, we might have a null hypothesis that a machine is functioning properly. Alternative, the machine is not functioning properly. So we're going to assume the machine is functioning properly. We're going to take some samples. If that comes out to be compelling evidence, overwhelming evidence, something that would be unlikely to happen under the assumption that the machine is functioning properly, then we're going to reject the null, accept the alternative. Alright, the way we set up these hypotheses, let me start over here with the two-tailed test. We might say a mean is equal to a certain amount, and the alternative is the mean is not equal to a certain amount. So we use the example, a realtor is telling us that the average rent is such and such. We said, we don't believe you, it could be high, it could be low. And we're going to set up an alternative hypothesis where what you say is not true. Now you recall for a two-tailed test starts with this equality, something equal to something else. And then there are two ways that that could not be true. That could be, the mean could actually be much lower, or the mean could actually be much higher. So we're going to set up a rejection region in the lower and upper tail. We also looked at hypothesis tests. One-tailed hypothesis test where we're saying, all right, the mean is greater than a certain amount is our operating assumption of our null hypothesis. And then we said the alternative would be, no, the mean is less than some amount. So here we would set up a one-tailed test. We would say, all right, you say the mean is greater than or equal to this amount. All right, I'm going to assume that's true. All right, I'm going to say that's the mean equals whatever you say it is. But I'm going to set up a rejection region over on the lower tail and say, this is 5% of the time, 1% of the time, whatever. And if my sample mean falls in that range, I'm going to reject what you say and assume the alternative. And we could do one-tailed, upper tail, same sort of reasoning. Generalizing the testing procedure. So we'll state the null and alternative hypothesis. Think about what we're trying to test in step one. Choose a test statistic. What this means in the procedure is choose, are we using a Z statistic or a T statistic, were the two we looked at last time. And we choose a significance level for our test. So a significance level is our threshold for unlikely. So if we're going to say a 10% significance level, we say if it's less likely than 10%, we're going to reject your null hypothesis. And we just need to decide what level we're comfortable with. How confident do we need to be before we say, I think your assumption is wrong. Compute the value of the test statistic from your sample data. So we're going to go out and get some sample data to prove or disprove the null hypothesis, or, to test the null hypothesis. I shouldn't say prove or disprove, just to test it. And then we're going to see how many standard deviations above or below the mean our test statistic is, given the assumption of a true null hypothesis. And then we're going to apply the decision rule and make the decision. And our decision rule can be made one of two ways. One way is our critical value region, critical value version. In that case we said, well, if, depending on our significance level, we're going to find a z value that represents the cutoff for our rejection region. So we're going to find the 5% of the data in the upper tail, 5% of the data in the lower tail. If we're looking at a z-distribution, that would be 1.65 positive, 1.65 negative, and if our test statistic is outside of that, meaning greater than 1.5 or less than negative 1.65, we reject. We could also use the p-value version. Now, the significance level is our threshold for what we would believe for unlikely behavior. The p-value is the exact calculation for our test statistic, exactly how unlikely. So the significance level might be 10%, so anything less likely than 10% we reject. And our p-value tells us exactly how much less than 10% it is, or it could be greater than 10%, and we wouldn't reject. And for the p-value, you find the test statistic, you find the area under the curve associated with that test statistic, and for a two-tailed test, you need to double it, because when you start a two-tailed test, you don't know if the sample statistic is going to be high or low. So we're saying, let's find the probability of getting something at least that extreme on either high or low. And for a one-tailed test, you do not need to double the p-value. Or you do not need to double that area under the curve to get the actual p-value. Okay, so that's that. All right, and then I guess we've kind of already pre-reviewed this, but we're going to review again. Two-tailed test starts with inequality. You say the mean is equal to some amount. Alternative, no, it's not equal to some amount. There are two ways we could disprove that. We could get sample data that is really, really high or really, really low, in which case both cases we would reject the null. So, level of significance. If suppose it's 10%, we divide that by 2 and put 5% in each tail. Find the critical value, and if it was 5%, it would be negative 1.65, positive 1.65, and we would calculate our test statistic, which I will review on the next slide. So let me actually just do that right now. Okay, so let's turn to the next slide. So suppose we're doing a sample mean, and we're calculating our test statistic. We're using the z-distribution, so we'll call it a z-statistic. We take our sample mean that we collected when we were trying to figure out whether or not to believe you. We find the difference between that and what you say the true population mean is, and we divide by the standard deviation of the sampling distribution of the sample mean. So this tells us how unlikely our test statistic is, specifically how many standard deviations it is above the mean. And you will recall that the standard deviation of the sampling distribution of the sample mean is the population mean divided by the square root of n. Alright, so we've got our z-stat. Let me go back to the previous slide. Once we have our z-stat, we can find our p-value. We look under the normal table and find the area under the curve associated with that z-stat. For a two-tailed test, multiply that by 2. And we apply either rejection rule. Alright, is our z-stat more extreme than the positive and negative critical values? These two lines mean absolute value, so yeah, they're just saying, is it more extreme on the negative side, more extreme on the positive side? Absolute value just means the distance from 0. Or we use the p-value version. If the p-value, the probability, exact probability of this test statistic is less than our significance level, which was our threshold for unlikely, then we reject the null hypothesis. Alrighty. We already went over test statistic. Alright, and this is the graphical illustration of this. Now this is, if it's sampling, I'm going to abbreviate this, sampling distribution of the sample mean. Alright, this is the great thing we have that makes so much of what we do in this class possible. This is a frequency distribution of every sample mean. And we know, because it's normally distributed, that the means are going to fall in a certain manner. Right? The percentage of the data is going to be a predictable number of standard deviations away from the mean, the center of this distribution. And if we have a rejection region, we can quantify, say 5% of the data in the upper tail, 5% of the data in the lower tail. We can quantify that with a specific z-value. We're using 1.65 for the cutoff between the upper 5% and the bottom 95%. Also, negative 1.65 is the cutoff between the bottom 5% and the upper 90%. So if our test statistic lands in that rejection region, we reject the null hypothesis. Alright, next slide we have a definition of p-value. You've heard me say it a number of times. I'll read it once more. P-value measures the probability that if the null hypothesis is true, we would randomly produce a sample result at least as unlikely as the sample result we produce. Okay, fine. Find the area under the curve. And if it's a two-tailed test, double it. If it's a one-tailed test, don't double it. And we can apply the p-value decision rule as we have discussed. Alright, so we're continuing to review. Now we're just doing a review of a one-tailed test. I have a few scribbles on here as I was preparing. Let me remove this, one of the scribbles anyway. Alright, so for one-tailed test, there's only one way we could disprove a null hypothesis. So, alright, faked you out. Let me put my scribble back on here. So suppose we have a null hypothesis that the mean is less than $20. Like the average amount customers spend at the concession stand is less than $20. Oh wait, greater than. Okay, now I'm trying to like prove, I want more funding or something for my concessions. I'm like, oh, the customers spend more than $20. So you look at that and you say, well, I think they actually spend less. And I'm going to find evidence for that. I'm going to see if I can find evidence for that. And if I do find that evidence, I'm going to reject your null hypothesis that the mean is greater, and I'm going to accept the alternative that the mean is less than $20. So, alright, so let's look at, sometimes, I haven't really talked about this too much, but sometimes I will put underneath the normal distribution graph, I will put the actual numbers and the z values, z numbers. I'll say z values. Okay, so the actual number was 20 for my null hypothesis, my mean, my supposed mean. I'm saying it's 20, maybe it's high as 22, you know, it's at least 20. I'm going to erase that 22 because the only important number here is the null hypothesis of 20. You, in your attempt to verify this information, you're going to say, well, what is our critical value if we want a 5% significance level? That's our threshold for unlikely. We're going to choose a critical value of negative 1.65. If we find sample data that is more than 1.65 standard deviations below the mean, your mean of 20, then, or my mean of 20, then we're going to reject the null hypothesis. So, sorry if this is confusing, but what I was trying to do here is, say we've got our so say we come up with a sample mean of $14. Okay, so we've got our sample mean of $14. And you say, well, wow, that's significantly less than $20. Is it enough less than $20 to reject your null hypothesis? Well, we're going to need to find out. So we're going to need to crunch that test statistic, that $14, find out how many standard deviations it is below the mean. And if it is more than 1.65 standard deviations below the mean, we're going to reject the null hypothesis. Okay, so I don't know if this attempt was successful, but what I wanted to do is just draw your attention to, we have the z-values, which is standardized. The mean of any z distribution is 0. And we know that below 1.65 standard deviations on any normal distribution, there will be 5% of the data. We also have our real numbers, the $20 concession, and our $14 mean sample mean. And there's of course a sample size and a population standard deviation that I did not include on this. Okay, so that was a quick review of a one-tailed test. We could do the same thing on a upper tail, and it would just be the different statement, the null hypothesis, the alternative hypothesis would be flipped around, and we would have a rejection region in the upper tail. Alright, so that is a quick review of Class 4. We're going to move on now to the real material for Class 5.